Hi, my name is Callie Chappelle, and in this video, I'm going to be teaching you the basics of programming in R. This is part of the Introduction to R tutorial, Bio 47, Introduction to Research in Ecology and Evolution, a class at Stanford University. These videos were created in spring of 2020. In this video, I'm going to be covering at a very high level and not in much depth a wide variety of topics, just getting you started with programming in R. I'll be talking about data types, objects, functions, packages, loading in data, our data frames, plotting, and briefly about linear regression. I'll be going more in depth on interpreting the output of the LM function, which I'll explain what that is, in another video. So if you came for that, you should go to a later video to learn more. So just starting out in R, there's a bunch of different types of data in R. So you might think, like numbers are different from words, and that's also true in R. So some of the most basic data types include numerics, which are numbers with decimals, integers, so natural numbers. Integers are also numerics. So an example of that would be 4 as opposed to 4.5. Logicals, so that's Boolean values like true or false, and then characters. So these are kind of text or written out words. So quotations around text indicate that it's a character. So for example, cat, and here's an example of that, cat with some quotations. You can define variables in R by using this, what looks like a arrow pointed to the side. We call it the assignment symbol. And so you can see the value stored in a variable by typing in the variable name and hitting return or using the print function. Now this might not mean a lot, so let me do a couple of examples. So here we are in RStudio, and I explained how to install R in RStudio in a previous video. And I just want to show some examples within R of these different classes. So if I type in the number 1, that would be a numeric value or a integer value. So if I run that line, it's just going to give me back 1. Because it's a numeric, I can do some math on it, right? So I can write 1 plus 1, enter, and it'll give me 2. And again, remember, this is just where I'm writing down what the commands are, and it actually is run down here. So I'm hitting Control Enter in order to run it down here. Now we can compare that to characters, right? So remember, I can type words or whatever I want in quotes, and it'll be coded as a character. So if I run that, I get cat. So just to prove that this is not an integer, I could write cat plus 1. Do you think that'll work? No, it gives me an error because you can't add a character and a numeric. All right, so what if I want to write cat many times and instead of writing out cat, I am lazy and I want to write the letter A instead? I can store the character cat or the character string cat into another object that I can call later. So I can write A, and then remember, that's the store this thing as the other thing, and write cat, and run that. And so now when I type in A and run it, it gives me cat. And you can see here in the environment tab, I've got A, and it represents this character cat. Now B, I already had represented 2, so I'll just show you how I did that. I can write B and an arrow and type in 2 and run that. And so now when I type in B, it gives me 2. Now what if I don't want A to mean cat anymore? What if I want it to mean the letter or the number 1? So I can write over something by storing 1 as A now. And now when I type in A, you can see it changed here. It gives me 1. And so I can use these objects just as if it was the other thing. So for example, I could write A plus B, and because A now represents 1 and B represents 2, what do you think it'll give me? It gives me 3 because it knew to add 1 and 2. So getting back to my presentation here, you can see that I can define an object using this arrow key, or using the pointing arrow. And these objects are things that are stored in these name containers in R. So they can be variables, they can be functions. You can see in my example, I stored numerics and characters as objects, and they can be seen in that environment workspace. Now, just a couple of tips on naming things. I would encourage you to avoid capitalization, spaces, or special characters, because R is very particular that you write things precisely. So, okay, A is represented as 1, but what happens if I type a capital A and run that? It doesn't recognize it because I stored it. The object here is lowercase a. So you need to write things precisely in order for R to know what you're trying to talk about. The next thing I want to explain at a very high level is functions. So you can think about them as these kind of predefined things that you can do to an input. So for example, if I write square root of 9, it will give me the square root of 9. So here we go, square root of 9, running that, and it gives me 3. Because R knows that when I type sqrt and then parentheses, and then put some input, in this case 9, into it, it should give me the square root. So the sqrt, and then these parentheses, that's the function here. So the input to a function can be just a number here, but it can also be an object, right? So let's say that I want to store a as not 1, but I want it to now represent 9. I can do that. You can see that a means 9 up here. Now I can write sqrt a, and if I run that, it should give me 3. And indeed, it does. So again, this is a very high level introduction to functions, but many of them are built in, like this square root function. You can write your own functions. I'm not going to get into that right now. You can also get extra functions that aren't built into R by installing packages. So I'm going to talk about packages now. So when you first install R, all you have is what's called base R. So base R is actually just a small portion of the total functionality that R can have. So you can actually add in other stuff that R can do, some extra modules that will let you do more things than in base R, and these modules are called packages. So to install a package, you can use this function, install packages, and then write the name of the package in quotes. And again, when you're first getting started, we'll tell you what packages you need to install. And you can write it like that. So let's do that. I'm going to write install.packages, and then the package we're going to install is gplots. So I'm going to run that. You can see that it is installing that package now. So once a package is installed, you don't have to reinstall it. So if I go here into packages, these are all the packages that are built into base R, but if I go look for gplots, it should be there. Let's see here. Where is it? Okay. Gplots. Yep, there it is. Gplots. And if I click on it, it'll actually give me the help page, so it'll explain how to use this package. So now it's installed. If I want to use gplots in some analysis, and so the first time I open R, I don't have to just have it installed, I have to have it loaded. So to load a package, you type in library and then the package that you want. So again, you only have to install the package once, but you have to load a package every time you run a script since the first time you opened RStudio. So I'm going to type in a library, gplots, and run that, and it will get everything ready for me to now use that package in the rest of my coding in R. So the next thing I want to explain is how to load data into R. So the first thing I would encourage you to do is to have data in a general file format. So for like spreadsheets, it's .csv or comma separated value format. So an example of this that you might be familiar with is like a .docx file is specific to Microsoft Word, whereas .txt file is general text file. Same with .xl. Oh my gosh, I can never say this. XSLX, which is specific to Microsoft Excel, versus CSV, which is kind of like a general datasheet file. You can think about it that way. So we can use the function read.csv to read in a CSV file. And what you need to tell it though is where. So the read CSV function asks you to give it a file path, which is where to read the file in from. So this is a little bit confusing, but what this essentially means is if I go in files, if I go to the kind of top level folder where I am, where the R project file is, inside of this subfolder, data, there should be another data sheet in here called analysis tables. So I'm going to go into the folder data, then analysis tables, and then look for this file, JR Nectar Data 2012 CSV. Okay, so analysis tables, right? What was it? Yeah, analysis tables, and then JR Nectar data 2012. So there we go. So the input telling it where to look is go look inside of that folder data, then look inside of the folder analysis tables, and then grab me the CSV file. And not only can we just read in the CSV, but we can now save that CSV file in an object called mimdata. So that's what this line does. So as a pro tip, always make sure that your data is saved in the same folder or a subfolder of your R project file, and then define the location relative to where the R project file is. So when you're running R scripts on a bunch of different computers, sometimes R can get confused about where to look. So if you always save your data that you're analyzing in the same folder as your R script and that R project file that I explained earlier, then R will always know where to look. And it's okay if you have your data in kind of subfolders like you see here, but always make sure that it's in at least the same folder or a subfolder of where that R project file is, so R doesn't get confused and lose track of where your data is. Now, how do you actually analyze or look at data in R? So data frames are what we call the spreadsheets, and again, air quotes, of R. So that's kind of how data in rows and columns get encoded. And they can be stored as objects. So in our case, we read in the CSV file and we're calling it an object called mimdata. And we can get a bunch of information about a data frame by typing these different functions. So like head will show you the first few lines of a data frame. Summary will show you the summary stats for each column. str will show you the type of data in each column. And that's relevant to the types of the classes that I explained at the beginning. And if I type in names, it'll show me the column names. And just a pro tip, any code behind a hashtag, and this is not just specific to R, but a lot of other programming languages are considered commented and therefore not run. So what I'm gonna do now is actually open that examples.r file and walk you through it a little bit. So this is our, as you might guess, examples file for new learners of R that will help guide you through our homeworks. So as you can see, the first thing that you do is load that gplots library. So I'm gonna run that. And I'm going to load some functions. And again, you can read through this. There's very detailed explanations that are in this commented out section that explains what everything is. I'm going to run the get working directory. And look, here we go. This is going to load in our data frame. So what this does, again, is go to this location, go in the data folder, then go into the analysis tables folder, and then go grab this CSV file and store it as mimdata. And as you can see on our global environment, mimdata has showed up. And you can see that there's a bunch of different columns that have different column names like plant number, year, week, flower, bagged cage, stigma, age category. And that looks kind of like a spreadsheet, and indeed it is. It's an R data frame. If you don't understand what some of these things are, which would be very understandable, you can actually load in this table descriptions. And that is a sheet that explains what all those columns mean. So this is a good data practice. When you create a spreadsheet or someplace where you're storing data, you always want to create what's called a metadata file that explains what everything is. So a new person looking at the data, like yourselves, can read and find out what does age category mean. All right, so here's where we were in the PowerPoint. I'm going to run a couple of these lines and it will explain what it does. So head, mimdata, will give me the first couple lines. Summary, mimdata, will summarize the information in each column. So for example, plant, it'll tell me the min, the first quartile, median, mean, third quartile, and the max of information in that column. str will tell you the data type. So remember, we talked about integers. So plant is integer, year is an integer, week is an integer. That all makes sense. Cage is logical, so true, false. Remember those Booleans. Stigma, it's open or closed, and it's a character type. And you can so on and so forth. And then finally, names, the names function gives us all of the column names. So getting back here, you can call data from a data frame in a couple different ways. The first way to do it would be writing the name of the data, name of the data frame, and then the row and the column, and it'll give you what is there. So for example, if I wrote mimdata 1, 2, it'll give me 2012. So we can just try that real quick. I'm just going to type in right here. And again, I'm doing a capital D because if I did a lowercase d, I wouldn't know what I'm talking about. So mimdata 1, 2, and look, it gives me 2012, just like I said, because it goes into mimdata, goes to the first row, second column and gives me 2012. Perfect. You can also call full columns by name by typing in the name of the data frame, then the $, and the column you're looking for. So if I wrote mim data $, then the name of this column, it would give me this entire column. So we can try that. $, and then you can see that it's really smart and it'll show me all my options. So instead of typing it out perfectly, which I am prone to make many typos, I can just click on the right one. If I run that, it gives me all the data that's in that column. And oftentimes you don't want to just print it out. We'll actually want to take this and do something else to it, and you'll see us doing that in a little bit. Now, the last thing I want to show you how to do is plotting in R. So a function that you might use is plot. And what plot asks is it'll plot data if you give it X and Y. So the X, I'll give it from the mim data frame, the nectar microliter column. Then for the Y, I'm telling it go into the mim data frame and give me the bacterial CFU per microliter column. And so it will give me this plot with this nectar microliter on the x-axis and bacterial CFU per microliter on the y-axis. So let's try that. Here in examples.r, these are just some things I was messing around with, so I'm going to delete that. Reloaded this. I can also highlight multiple lines and run them all at once, but here's that plot. So I'm going to run this line, and you'll see that in plots, there's our plot. Perfect. So remember I was telling you you're going to use that plot tab? Here it is. All right, so maybe that plot doesn't have what you want it to have. For example, that plot has some pretty weird X and Y axis names, and that doesn't make any sense. So maybe we want to add or change things by adding options. So we already had X and Y before, so this is the same, defining the data for the X and the Y axis, but we can also give a title to the X axis by writing XLab and then the name of what we want on the X axis. Again, remember these are characters, so they gotta be in quotations. The name of the Y, define the title for the y-axis, and we might want to rotate axis labels so it's easier to read. So this is, if we just continue on here, we can, for example, log transform the data. So what this line does, just before we get to more fancy plotting, it says, give me the log 10, so this is a function, take the log base 10 of the column of the mim data frame, bacterial CFU per microliter, add 1, and then take the log 10. So remember, this is the same order of operations that you would see like in an equation, right? So it'll first do this, it'll give me this column, add 1 to every single thing in the column. So again, so here's the data frame, here's the column I think that we're using. I think it's it's bacterial CFU per microliter. It's going to add 1 to each of these observations, and then it'll take the log of it, and it'll put that into a new column, log back CFU. There we go. Because this is what we're doing. So take that column, add 1, take the log 10, and then store it in the mim data frame in a new column called log back CFU. So that's what I just showed you. So that's this, log back CFU. All right, so after I did that, now I actually want to do some fancy plotting, so I can adjust the axes by running this line, par, and then I can run this line of plot that I just walked you through all the lines do, and then I can add a title here, and there we go. So there's our updated plot. We've got our y-axis goes from 0 to 5, and our x-axis goes from 0 to 10. And we have different X and Y axis names, and we have a title. Perfect. Exactly what we were looking for. So the last thing I want to tell you about is linear regression in R. So the LM function will do linear regression, and what you give it is the column that is going to be the Y and the column that is going to be the X. So this line says, use the LM function, do linear regression of, on the Y, the column log back CFU, that's the one we just made, and on the X, nectar microliter, both from the data frame mim data, and store the output of that linear regression as this object, model.back.nectar. And then on a separate line, summarize the output of that. So let's run that in RStudio. All right, so first, I'm just going to actually not save this as an object. I'm just going to run it first. Okay, so I just ran this one line. There's the line, and you can see there's the output. It gives you the coefficients, and it shows you what the equation was. All right, but that's not that useful because we want to be able to do stuff with it. So we're going to store it as this variable model back nectar. So I'm going to run that, and you'll see nothing happens because I didn't call model back nectar. So if I do, so if I just type in model back nectar and hit enter, what should you get? We should get this. And indeed, we do, because now model back nectar represents the output of this function. All right, but this is just a little bit of data. We actually can get a lot more data from the output. So if I write summary and then our object that represents the linear regression that we did, the linear regression model, then we actually get a lot more information. And in the next video, I'm going to go line by line and explain what each of these things means. All right, thank you very much.